So I would like to present in this demonstration the model that we have developed together with Anna and Konstantinos Koutroubas at the National Observatory of Athens. It is a machine learning model to detect and forecast LSTIDs over each digital station separately. And we are based on a deep neural network architecture, which is called temporal fusion transformer, and it is mainly used for time series analysis. So as you can see from my screen, what I have here is a Jupyter notebook. Our machine learning model is developed using Python. And in this Jupyter notebook, I have loaded two classification models, one for the Sopron station and one for the DURBS station. So the models are already loaded in the memory of the notebook, and I will provide a brief demonstration. I will execute the model for different periods for each of the stations, let's say. Let's start. So our model has 1, 2, 3 parameters. The first parameter is the forecast horizon, which means how far in the future we want to make our prediction. The minimum value of this forecast horizon is from 5 minutes to 40 minutes, let's say, where we have seen that we have a good forecasting capability. So I will leave for the moment the forecast horizon to 5 minutes. The second parameter is theta. Theta is a threshold parameter above which we assume that an LSTID occurs. Theta can be 50% or 70%. And also I would like to mention that our models have been trained and validated and fine-tuned using data that we have been captured from these stations from the start of 2022 and up to June 2024. So as a testing period, I have selected here the period starting from 1st of June 2024 up to 24th of July 2024. So to present just an example and how the code runs, I will arbitrarily choose, let's say, 5 days and perform a prediction for the DURBS station with a theta of 70% for just 5 days of data. So I hit the button forecast, and now the model runs on the background. It loads the data for this specific. So the model runs on the background, and the output of the model is the following. We have measurements from 9 of June 2024 up to 14 of June 2024. The first figure are the IL and IQ indices that come as input to the model. Next figure is the GNSS GradTech, which is also an input to the model. And on the final figure, we can see the output of the model, which is 0 or 1. It is the curve with the red line. We assume that class 1 is the occurrence of LSTID, class 0 is the non-occurrence. And as you can see, the output of the model follows exactly the pattern of the sec values over DURBS. Let's try to make the same prediction in a separate experiment using the same parameters, but for the Sopron station. I hit the button forecast. The model loads again the data from the station and comes in the inference mode, which means that it predicts the outcome. I have to say here that although training a neural network model takes a lot of time, when we are in the inference mode, then the time is relatively short. That's why I can show you in real time the result. And the result for this experiment is the following. As you can see again, here we have the sec values from the Sopron station. And the output of the model follows exactly with some more positives, but follows exactly the pattern of the sec values. That's why we can say that the TFT model has excellent performance in predicting the outcome. Of course, if I change the forecast horizon, for example, and set it instead of 5 minutes, which is the minimum value, if I set it to 40 minutes, it will take some time. Let's set it to 15 minutes. Then the output might not exactly follow the pattern of the sec values. We will investigate this in a minute. Again, the model is executing in the background, and the data is loading, and we are in inference mode. So it will take a short while to come up with the result. Of course, this is just a demonstration. This is a simple Jupyter notebook. Since our code is written on using Python, we can deploy the model in real time in any machine, in any container. Again, you can see here that we have loaded the sec values for the specific time period from Sopron station, and the forecast horizon is set to 15 minutes here, and again, the output seems to be good. Whenever the sec values are over 70%, which is the horizontal gray line here, our model correctly predicts that we have the occurrence of LSTID. I can run another example for the Durb station for a different, let's say, time period, 5 days. And let's run forecast again. The prediction comes in less than a minute. So as you can see that the predicted output follows exactly the pattern of the sec values in Durb station that are over 70%. The results are good. I hope this demonstration shows in general how the model works and what is the input, what is the output of the model. I don't know if you have any questions or if I could run an example or an experiment that you would like to see specifically.
Thank you, Costa.